Okay, good morning. So, unfortunately, I'm sick today. Hopefully, I can finish at least the first homework. Not many of you actually joined the homework. I don't know why, but let us go through the problems one by one. There are three problems. I mean, the questions are not hard, but as I told you, the questions are at A level. So you need to read and understand them. The algebra is very minimal, but understanding the text and how to prove is important actually. So let us go through the first problem. What the problem is, let m and n be distinct natural numbers such that m minus n divides m. Show that m minus n divides n. Yeah, so it means that if m is divisible by m minus n is also divisible by m minus n. So that is what we want to show. Okay? So m and n are natural numbers, question number one. And they have mentioned that they have mentioned that m and n are not the same, they are distinct. And we know that m minus n divides m. From here, we can conclude that the same number m minus n also divides n. Okay, so that is the goal. Okay, so there's only one thing we can do, and that is using the definition of divisibility. Okay, you are telling me that m minus n divides m. According to definition of divisibility, I can grant the existence of an integer q. So there exists q in Z, so there exists an integer q such that the number on the right is equal to the number on the left multiplied by q. So that is what is the definition, yes? If you tell me this, I am allowed to write that. But then, from here, doing probably simple algebra, the algebra involved usually is not that complicated. I want to find a way that on the right-hand side, n appears. Because I want to show that n is also divisible by m minus n. So I have to have a relation in which n is on the left side here in this equality, and then m minus n appears here with some multiple q. But of course, the q is not usually the same q, and that is important to understand. So what should I do? So because you need to be able to think in that way, otherwise you get stuck. So you see, this is my equation, equality. In order to reach here, I need to have n on the left side of the equality because I want to say something about the divisibility of n by m minus n. It motivates me to do something to this equality, so something valid mathematically, so that the left-hand side, instead of being m, now becomes n. This is the way that you need to think. I'm not saying that if you don't think in that way, then it would be random calculations and it will not allow you to solve the problem. Okay, now can you tell me, in very simple terms, I have equality, the left-hand side is m. By looking at what I want to show, I see I need n. So I ask myself, what can I do to both sides of equality so that instead of having m on the left, I will have n on the left? So this is the question that you need to answer. Okay, might be there are different ways, but then at least you have a strategy. You start doing trial and error with all those possibilities. So hopefully one of them will work. But here we do not have that much option. So can you tell me what can I conclude from here? Tell me so that what should I do so that instead of m, I have n? Yes? Okay, if I do that, then n and q will go to left together. We cannot separate them. So if you are saying is that I multiply that, it's become mq and nq, I agree with you. Then you will have minus nq. You have to move both n and q together to the left. Okay? But this is not exactly what you want. But that is a good way of thinking. This is a trick, this is a technique. The strategy is clear now. The strategy is to make this n rather than m. That technique is not probably that useful because now you understand, if I want to follow what you said, both n and q will go to the left. I just need n on the left. Okay, so this is not working. But you shouldn't forget about your strategy. Your strategy is still the same. I want to have n here. That didn't work for this reason I mentioned. Okay, what is the other choice? I'm sure that you know, because that is the only reason. If you cannot continue, then it means that you have to leave this question unanswered, and that is a very simple question. Okay, if I ask you, make something so that this becomes n, because if I write the solution, you will immediately understand, yes, I could do it myself. That's why I'm waiting for you to answer. So let me give you a hint. Add something to both sides. If two numbers are equal, if I add the same number to the left and do it to the right, the results will also be the same. So that's a valid way of continuing. So, but what should I add to the left so that it makes it n rather than m? Then it is extremely simple. You should be able to answer this question immediately. What should I add to m so that it becomes n? What are you thinking? What should I add to 2 so the answer becomes 5? What should I add? 3. Okay, that is for Grundschule. Now you are in Math 5. So now my question is that what should I add to m so the answer becomes n? Yes, Musa? Yes. So what the question mark should be what? N minus. Yes? So is the algebra complicated? You need to ask yourself why I couldn't do that. Okay? So now I understand. What I will do, I will add this to both sides. You see, I am following my strategy. Might be my strategy is worthless, but it is not clear yet, but that is a strategy. What I'm doing, I am adding this to both sides. What will happen? So this becomes m plus n minus m, and then m minus n times q, and then plus n minus m. First of all, you have to understand the logic is clear. Do you agree that from here, from this equality, I can write this equality as well? Why? Because if you grant me this equality, and I add the same number to both sides of this equality, I still can keep the equality. So that is logical, valid. But why this is useful? At least you see that this m and m are gone. And what is left for me is exactly what I need. Do you remember? I need n alone on the left-hand side. So I have it. Might be it is not working, I don't know, but at least I have my n on the left. Okay, but then let me write, because let me copy and paste everything on the left. Okay, is it useful now? Because my goal was to have n on the left, I have it. What I want more, I want to have m minus n on the right multiplied by an integer. Yes? It seems a little bit messy, but it is not hard to organize it now. Can you see that? I want to have m minus n times an integer on the right. Because I already have my n on the left. If I can have m minus n multiplied by some integer on the right, then the next step is that immediately I can conclude this. Do you see that or not? So what should I do? I want to have m, here is m minus n, here is n minus n. Can I factor something out? Not in this form, because this is m minus n, this is n minus m. Whenever you have the wrong sign, you need to think of one trick, and that trick is to pull out a minus sign first. Okay, so what I will do, I will continue, and I would write n equals to m minus n times q. But I hope that you agree with me here. I can write m minus n, but I have to put a minus sign out. Is this correct? Yes. You see, n minus m is not what I needed. I needed m minus n to be able to factor it out. So I call it the wrong sign. Whenever you have the wrong sign, remember this trick. Pulling a minus sign out might be helpful. And it is helpful. Do you understand that what I have written is correct? Because I just copied and pasted this part. Instead of plus n minus m, I wrote it in this form. Is that right? Yes, because let me multiply the minus sign in. So it becomes minus m plus n. And that is minus m plus n. So what I have done is good. But why it is useful? So you have to have it right, you have to have it useful, both of them. Is it useful? Yes, because I can go one more step, m minus n, I can pull it out. Yes? Okay, but now what type of number is this? Q was an integer. So Q minus 1 is also guaranteed to be an integer. So this is definitely an integer. If it is an integer, I can give it a name. So if you don't mind, let me call it capital Q. So then what happens? N becomes m minus n times capital Q. But what type of number is capital Q? Is an integer. Yes? I'm explaining too much because I want you to understand how to act. Because you see, the algebra is even simpler than probably Ma2C algebra. The point is that understand how to solve the problem. Okay, can I conclude the problem and finish it? Yes, because m minus n multiplied by an integer is equal to n. So it means n is divisible by that number. In other words, m minus n divides n. Yes? So that is what you have to write for this problem to be able to get. I'm not saying that 100% you have to follow me, but the logic is this. Is that clear? Yes? Okay, so you have to think, otherwise this is useless. You have to sit down and think about the problems before coming to the solutions. Okay, so let us go to the next problem. Of course, the next problem is a little bit harder. So let us read the problem. Yeah, sorry for my voice, I cannot do better now. So let x and y be distinct natural numbers, okay? Both greater than 1, such that x minus y divides 3x minus 1, and x squared minus y squared divides 3x. Show that x and y are consecutive natural numbers. Consecutive means one after the other, immediately. I don't know how many of you have thought about the problem. Might be it's a good idea if I pause recording and give you time. Yes, two birds with one stone. I can rest my voice. You can also think because you don't think. I work more than you. Yes, because when I'm behind my system making questions every week, 12 questions, but at least you need to bother to try it out. Yes. Okay. So I will give you a little bit of time at least to think about the problem yourself first. Okay, do you have any idea what to do? Yes?
Can you start off by writing
Yes, the definitions. That's what we have to do, yes? At least the first step is easy to do. You see, I know that x and y are natural numbers. I know they are distinct. It means they are not equal. The reason I excluded that because I want to avoid this to be zero. Divisibility by zero is a little bit problematic. So I don't want you to keep you busy with thinking about that. But the point is that I have two assumptions. So I have to use them. And you know that I have to show that x and y are consecutive. What does it mean? It means that x is either one unit more than y or one unit less than y. So that's the meaning of being consecutive. Yes? Or the other way around, it doesn't matter. So what should we do? We start with the definition of divisibility. What is the meaning of this? This means that the right-hand side, so there exists a Q in Z. I hope that you are not having a hard time writing a symbol. If you don't like it, just say that there exists an integer Q, okay? But this is simpler to write. The right-hand side, the number on the right, is equal to the number on the left multiplied by that Q. That's the meaning of this, yes? And then we translate this one in more or less the same way, but you have to be a little bit careful about one point. Let me see if you remember it or not. So when you say that this divides 3x, I can also write the same thing. Should I write q in z such that the number on the right is equal to number on the left multiplied by q, or there is a small flaw here, yes? What should it be? Q prime or any other letter, because if you write Q for this and Q for this, you a priori is assuming the Q's are the same. But this is not guaranteed because we don't know X, we don't know Y, so how we can assure that these numbers are the same? So to leave this possibility, to make this possibility a possibility, we have to put S Q prime there. Okay, so these are the translations. But you know that this is important. How do you think about the problem? You want to prove that x and y are consecutive integers. When you are interested to prove two natural numbers are consecutive, so you are interested in what combination of x and y? Yes? For example, are you interested in the product of x and y? No. Are you interested in the sum of x and y? No. What combination of x and y matters to you more than the other combinations if you want to prove two natural numbers are consecutive? Which combination? X minus y, the difference. So that is important because you have to translate this English sentence into a mathematical way of thinking. So this tells you that somehow you want to know something about the difference of x and y. So that's your target. Okay, so this is one part that I cannot help you that much. So you have to be a little bit creative here. Okay, so I don't know how many of you see. I can ask you to do it and wait for you again. That's a good idea. My guide for you is to find the difference between these two equations side by side. Okay, so what I mean, if this is equal to this and this one is equal to this, it is guaranteed that this minus that is also equal to this minus that. So I forgot to put a prime there, sorry. So I will wait for you again. This is the guide for you. Take this equation and that equation and subtract them side by side. And do some very small algebra to be able to conclude something about x minus y. Do it, it will appear. I hope that you can finalize it yourself. The only hint, probably, so you have to be a little bit creative to understand yourself that the difference between them will work. Okay, this comes by experience a little bit, so I will wait for you. So I don't think it is now hard. So what I ask you to do is to side by side subtract them. So let me do the algebra with patience, okay? I would write this one minus that one. But be careful, don't write it like this. When I say subtract both sides, you have to put a pair of brackets around it. Okay? And then, which one I wrote first? I wrote this one, so I have to write this one first as well. Minus that one. Yes? Okay, so this might be a little bit problematic if you don't have enough experience. Might be you cannot come up with a conclusion that this is useful. But when I gave you the hint, I was expecting that you will be able to continue it yourself until the very end. So let us see how it works, because this is extremely simple algebra. So what do? You write minus 3x plus 1, this minus sign goes in. And then you see this is a very famous pattern, x squared minus y squared. It's a Ma5, simplest possible conjugate pattern. So you factorize it with the same idea that this factorization will enable you to factor x minus y out. Okay? So if I factorize it, if this didn't come to your mind, you need to ask yourself why. So this is important to be conscious about what you are doing. Understandable? So what I have done, I have factorized this using the conjugate rule and copied and pasted more or less everything else. But what happens here, this one and that one are gone, I am left with 1. But between these two, x minus y is a common factor. I can pull it out. So what is left from here is x plus y cube prime, and what is there is just minus q. So you should have this experience by now. What is left for you? Sorry for that. So this one, you have to have this experience. If this is complicated, it doesn't matter for you. What matters is that this is what? An integer. That's it. Is it an integer or not now? Because x and y are given to be natural numbers from the very beginning. Q prime and q are also integers. So I hope that you agree that the sum is a natural number. When I multiply it by an integer, it is an integer. When I subtract two integers, it is still an integer. So that's the only thing that matters. So this is an integer. So if you don't mind, let me give it a name. So capital Q, for example. Then what happens? This becomes 1 equals to x minus y times capital Q. Capital Q is what type of number? Is an integer. Yes? But what is the meaning of this? It means x minus y multiplied by an integer, the answer is 1. So can you translate this into the divisibility symbol? Yes. X minus y should divide 1. Or 1 should be divisible by x minus 1, x minus y. But 1 is only divisible by two numbers. 1 is supposed to be divisible by this. So this means that what? X minus y is plus or minus 1. Is that right? That's the only option I have. But do you agree it means they are consecutive? This means that the difference between them is either 1 or minus 1. So one of them is after the other one immediately. Because the difference is either 1. If x is bigger, the difference is 1. If y is bigger, the difference is minus 1. There is no other options. So this means that x and y are consecutive. I don't know, is that understandable? Yes? So, of course, the people who are working in number theory, they can see these things much faster, but I don't want to confuse you. This is a level 3 problem because you have to do it in this way in your book. You don't have extra theorems available so that you can immediately use them. For example, x squared minus y squared is a product. Is a product of x minus y and x plus y. For example, if I want to solve this problem, I can do it faster. I would say a number is divisible by a product. If a number is divisible by a product, it is of course divisible by each one of them individually. Yes? So for example, immediately if I want to, I can conclude that x minus y divides 3x. Is that understandable? Because I have a number which is divisible by the product of two numbers. One of those numbers is this one. If a number is divisible by a product, of course it is divisible by each one of them individually. So if I want to, I can immediately jump to this conclusion. And then I have another theorem in my head that if one number divides two numbers, it will also divide the difference. It's not hard to prove. And in that case, x minus y divides the difference between them, but the difference between them is 1. So it becomes more or less very simple for me to understand that this is working, yes? But because these theorems are not specified in your book, I don't want to confuse you to memorize a lot of all those theorems. So this is one logical way for you to be able to do it. Understandable? Okay, so let us go to the next problem, which might be a little bit harder, but be careful. It might be harder, but now you have more experience. So let us read this first. Let x, y, and z be distinct natural numbers such that y divides x plus z, and x squared minus z squared divides y plus z. Show that y divides z. Okay, I think in principle, now that your memory is completely fresh about what we have done, in principle you should be able to solve this problem yourself. Because more or less, I want to wait for you, okay? A little bit longer to see if you really can solve this problem. For this problem, I don't think you face any problems for the first two parts. Just do it as before. So let us not spend so much time on it. So y divides x plus z. What is the conclusion? There exists a q in z such that the number on the right is equal to the number on the left times the q, and the translation of the second one in mathematical form. There exists probably another q prime in z such that the number on the right is equal to the number on the left multiplied by q prime, yes? So I'm sure that you could write this up to here. But the problem is that it is important to understand that, okay, what I'm supposed to prove is z is divisible by y. So I don't know, I want to hear from you. How do you think from now on? Because now the algebra is not clear. There are a lot of things that I can do with these two equations, but probably only one of them will be helpful. So it is not a good idea that at this point try to do random things to see which one works. You have to have again one strategy to be able to follow your strategy. So what is the strategy here? What you want to prove is this. What you have in your hand is this and that. So somehow you need to understand how is it possible that I can use these two and reach here. Okay, this is important. If you have a little bit of experience, it is not that hard to immediately see one step, one way to do it. I'm not saying that this one way definitely will work. Okay? But this is a strategy. It is better to have a strategy before doing something in mathematics. Okay, now can you talk about your strategy, your plan, your big plan for going, not technical, I don't want you to tell me do this, do that. No, what is your grand picture for how can I use this, go from here to there? If I have experience, immediately one observation comes to mind, okay? Okay, so that is not a strategy because what you have written is just translating this symbol into English language. No, plan. Okay, how you want to achieve this, that is your plan. Yes?
I would start with the conjugate.
No. These are technicalities. These questions that you're answering now are technicalities. Might be they are useful or not. but you should have a strategy to see if that technique is useful or not. Just because you see this conjugate pattern, don't open it up, because that is a random calculation. I want you to understand that. If you want to be a good problem solver, don't look at this problem. You have probably thousands pieces of information in front of your eyes, and then you want to find the best way. Try and error is not a good option at all. Yes? So what is your grand strategy? Yes?
Try to find some bond to equation.
Okay, but what you should have a plan. What kind of bond you are looking for? That is important. These questions that I'm asking are important. If you pay attention, you might be a better problem solver. Yes?
Maybe I need to isolate z and y and see if z is divisible by y. So I need this.
You get close, but that's not 100% what I wanted to mention. You're getting close. So that is one. So another one. So you see, when I was teaching you trigonometric identity, I repeated more or less the same thing that I want to repeat here. Okay? So, do you see any big difference between this one that you want to prove and the assumptions that you have? Of course there are big, the form is different. This is y and z, this is y plus z. Of course they are different. Try to ignore these details. There is one important difference between your assumptions and what you want to prove. What is that? That is, if you can find that I call a strategy. And then after you have your strategy settled down, you can think about technicalities as, for example, you mentioned, which might be useful or not. What is the main difference? I cannot explain more. Yes?
You know that y divides x plus z, so you need to know x.
No. A big difference between your assumptions and what you have. Can you see that? For me, it is not hard to see because I have trained my brain to think in that way, but it is evident more or less. Okay, try to see the differences because I want to practice. What is of course there are very differences between what you see, but the main difference is one thing that you are not mentioning that. And this I want you to learn. The reason I am intentionally making it long, because I want you to be aware of this way of thinking. So what is that? What did you say? Someone said something, I think. Okay, say something, okay? Try to say something. What is the main difference? Nothing. I intentionally want to wait because I have repeated this several times in my lessons, but still you forget because you are not very probably conscious about this. But say something at least, a guess. Yes, Ahmed?
The last is what z is only two that.
Exactly. Exactly. That is the strategy. What you want to prove has nothing to do with X. Was it hard to see? But you don't see it immediately. For me, I see it immediately. It doesn't mean it works, but I immediately have the strategy, then it will guide my algebra. Yes? Because this is important. If I have these two equations, I can do 100 things with these two equations. Add them, then subtract them, multiply them, divide them, raise them to power 5. You know, a lot of things I can do. But I have to have a plan to know what to do. So my strategy is now clear. These two both involve x, y, and z. What I want to prove is just related to y and z. Okay? This observation is not hard to make if you train your brain and eyes to catch these things. Okay? Now, what happens? Now, I hope that you understand this very important observation makes it clear what to do. I have two equations. This equation involves x, z, y, and q. This equation involves y, z, and x, and q prime. But I know what is my goal? My goal is to somehow write something in which x disappears. Is that right? Do you see that how this strategy is going to work? Okay, at least it guides you. Okay, in the middle of doing this might be what Abdullah said becomes relevant. Conjugate pattern and things like that. These are technicalities, not a strategy. Okay, so now my strategy becomes clear. Then I have to also have a skill in algebra and other calculations. Combining these two things, hopefully I will be able to solve my problem. So our strategy is clear. If I want to say it friendly, get rid of x. Is that right? And then get rid of x is not a strategy, is technicality. In a matter of seconds, you need to be able to get rid of x. These are so standard tricks that we are using it all the time. Might be you haven't appreciated them so far. For me, it takes microseconds. Not the best way, by the way, but microseconds to understand how to get rid of x. I'll give you 10 seconds to tell me how to get rid of x instead of microseconds. I'm saying that there is no guaranteed microseconds is the best option. It comes to my mind immediately, but at least I have a technique in my head. I am relieved because I know at the worst case scenario what I'm supposed to do. But I don't do it immediately because I will try to find a wiser way to do it, if possible. Do you understand? Are you hearing me? Yes? So tell me, in 10 seconds you need to tell me how can I get rid of x? Yes? No, tell me exactly what to do. I want to get, because my strategy is now in place. I want to get rid of x. Okay? And tell me, how should I get rid of x? Not the best way to get, but one way to get rid of x. Yes?
You find that expression for x that does not include x itself.
No, this is the goal again. You're repeating it. What should I do? For example, now tell me, do this, do that.
Isolate x.
Okay, from?
The first form.
Exactly. So that is the technique. So that's it. You find x from here and put it there. X is gone. I'm not saying this is the best way, but this works every time, if possible, yes? So what you do, you choose x from one of them and put it in the other one. What happens? X is gone. I am not saying that you get what you like, but your strategy is done. X is gone. Okay, but then the question is that, now I want you to understand the difference between a strategy and technique. You can find x from here and put it here, x is gone. Or you can find x from here and put it there, x is again gone. Okay? My strategy is good with both of them. But which one is more efficient in this case? This is technicality. Yes? Which one is more efficient? Of course this one. Because just by moving z to the other side, I have my x. But if I want to find x from here, I have to divide by q prime, I have to move z squared to the other side, I have to take square root sign. Okay? So this is the difference between strategy and technique. My strategy is to get rid of x. Both of them will work, but which one is more efficient? The first one. Okay? So, we have this strategy and now we know what to do. You see, this guided me. I want you to feel that this helped me. Can you see what I am telling you is helping you to solve the problem? Because this observation that x is not there was very useful to direct your algebra. Otherwise, which way you want to explore? There are a lot of ways in front of you. So this very crucial observation, which doesn't probably worth even to mention it, because when you were mentioning, you were a little bit doubtful even. But this is extremely important to have this observation. Okay, so Then I put it here. Then be careful. I am not saying do things blindly, because a skill is also important. If I put this there, you see what happens. Okay, I just want you to listen, okay? To Q prime. Sorry, this is not X, this is Y. Now, do you see what is happening? I achieved my goal. My goal was to get rid of X. Do you see X in here? So X is gone. But you might say, what is the point? This is horrible. This is why your skill matters. If you can't do algebra efficiently, or you want to do it by brute force. But it is also good to know how to do something by brute force. I am not underestimating it. But you have to be aware of all these. When I want to solve a problem, automatically I think about all these things. Okay? And this will come if you pay attention. But it doesn't mean that I can solve all my problems. The number of problems that I cannot solve is much, much, much more than the problems I can solve. Okay? Don't worry about that. Math will not become boring for you. So try to learn these tricks. Okay? Okay, so this is one way to do it. But now you see, I don't like this because I can do a little bit better, as Abdullah said. Now that this conjugate pattern is there, it might be useful. But if you don't see it, and if you are good in algebra and patient, and then you will follow, and I am sure that you will get the correct answer. But there is a better way to do it, but what you mentioned. Okay? So what I will do, instead of doing it, okay, so instead of doing it like this, I can do the other way around, okay? I can say that, okay, this is working, but let me see if I can find a better way. I factorize it because of the conjugate rule, yes? Yes? But be careful, still my strategy is to get rid of X. But let me see if I succeeded it. But be lazy always in mathematics. Don't do brute force unless you have to do it or you don't find any other way. So I go back here. Okay, now you can see what I do. This combination of X plus Z appears here. Okay? So instead of X plus Z, here what can I put? I can put Y cubed. This is a scratch work. I am going to scratch paper doing these things. Do you see that? But do I achieve my goal? Do I achieve my goal? Why not? Because X is still there. I'm not confused. I know what I'm doing. Still my goal is to get rid of X, but I'm trying to find a better way. This was a better way. Why? So let us do it from here. Okay? I will go from here, X plus Y plus Z is equal to. This part is YQ times Q prime. So far, very good. I don't see X, but I see X here. What I will do here, I will put X there. Yes? Are you with me or not? Yes? So, which one is suitable? This is easier a little bit. Yes? Because the algebra becomes simpler. Yes or no? Yes. Minus Z minus C can also be written as YQ minus 2Z. YQ Q prime. Are you with me? Okay. But still the problem is not finished. I will pause recording again. You have to finalize it yourself. Okay. This is at least I followed my instinct. I got rid of X, but still the problem is not solved. Yes. So I have to have another strategy again to guide the algebra from now on. So that's why I'm saying that if you don't know how to solve math problems in efficient ways because you don't learn this way of thinking, it comes very hardly in the beginning, but it becomes automatic in your brain. And you will follow just exactly what I'm saying. So you see, one strategy, one observation was very important here. It guided me up to here. But then I don't have a strategy, my strategy is finished, then I have to ask myself, I need another strategy to know what to do with this one now, because this is not exactly what I need. Okay, so again, let us review this. What do you have as a strategy now that will help you to continue? Yes?
You can move what the right hand side.
You want to move Y here. Why do you want to do that? Because this is your strategy again. Very good. So you are learning. Because if you go back here, what do you need? Y is the number alone on the left-hand side. So by looking at this, it will give you a strategy. Isolate Y on the left. Okay? If you see this is telling you isolate Y on the left, then probably, isolate, left is here. Isolate Z on the left. Because do you see that how this means Z is divisible by Y. So I have to isolate Z on the left. Okay? Now, if I say isolate Z in the left, you see again I have a new strategy in order. And I know that I want to isolate Z. Is it hard? But if you don't have the goal, you might say, let me move Z to the right, or let me move Y to the right. Let us see what happens. Yeah, you can do it sometimes if you really don't know what to do. Sometimes miracle comes in and you will find a solution. But this is very simple. So by looking at here, I know that I have to keep Z on the left. So what should I do? Tell me. I keep Z. What should I do? I move Y to the left. So for the time being, don't be horrified with this. Yes, these are just letters. Just write them. Yes, and Y, Q, Q prime. And then what do? I move Y to the left. Yes. So this was my strategy. But the final strategy is I want to have a multiple of Y on the right. Do I have my multiple of Y? It again guides you to do what? You see, you have a Y here and also a Y there. So can I pull it out? Yes, so I can factor it out. So what happens? This becomes Z equals to. I pull a Y out. What is left for you? This repeats itself. This Y is pulled out, so Q prime is left. Minus, what is left there? When I pull Y out? 1. Is that understandable? So now what happens? This becomes something, a horrible combination, but I don't care about the combination, because what matters to me is this number is an integer or not. That's it. I know Y and Z are natural numbers, even better. I know Q and Q prime are integers. Do you agree that this combination definitely becomes an integer? Because if you have if you have integers, you multiply them, subtract them, multiply them by other integers, it remains integer. So this combination, who cares about how big this is? It is just an integer. So this is an integer. So I can give it a name Q. So then let us write it here. Z is equal to Y times Q, but Q is an integer. So what does it mean? It means that Z is divisible by Y, or Y divides Z, end of story. Yes, is that clear? So try to learn these observations. For example, when I was teaching you trigonometric identities, I always tell you, look on the right-hand side, what do you have? And try to ask yourself, what can I do to the left so that I can get closer and closer to the right? Okay? So you have to have a strategy and then think about how that strategy can be achieved. That part is calculational skills, algebraic skills. If you solve more problems, you become faster in detecting those patterns. But it does not make you a good strategist. You should have a strategy, and then you should have technique available, a skill available to follow the strategy. Okay? So I don't know, might be if I have shown you this problem on the board, you might say this is extremely hard problem, but you see it is not a hard problem. You need to know how to think. The hard problems are exactly those problems that even if you know how to think, it is extremely hard to come up with some solution. So many mathematicians, especially the genius ones, they can immediately solve problems coming outside from the box. For example, they are solving a problem in geometry. They come out from geometry, translate that problem in algebra, solve the problem there, use what they got in algebra, come back to geometry and solve the problem. So this is very, very ubiquitous between brilliant mathematicians. But this level of thinking, if you pay attention, you will learn. And it will be helpful, not just in math, in chemistry, physics, biology, in every, this way of thinking you have to learn. Okay, any questions? Okay, so I will stop here.